Welcome everybody to lesson 1 of the High Bricks Cultivation System. So this lesson will focus on the 4 elements. And if you don't know what I mean by that, you'll find out in a minute. So we're going to cover in this lesson the importance of the 4 elements, problems that can be caused by each of these elements, and really we'll see that all problems with your plants and with your bricks levels boil down to one of these 4 elements, and how to work with each element in order to achieve that balance that's going to maximize your bricks and your production and just give you amazing results. So the 4 elements, we're talking about fire, air, water, and earth. So really, again, these 4 elements will be responsible for pretty much any problems that you have in your garden or on your farm. And really what we're going to see throughout this course is that the key with these is to achieve balance. And in fact, that's going to be a theme throughout this course as well, is that balance and diversity are 2 of the most important elements in your garden or on your farm. Now, talking about the 4 elements, this conversation may seem a little simplistic to some of you, especially if you've been growing for a while, but I believe it's really important to start out with and to lay this foundation, because I find that even some experienced growers really underestimate the importance of these 4 elements and getting that balance right. In fact, so many problems in a grow can just go back to very simple things like overwatering or underwatering. And so in order to lay the right foundation, it's really key that we focus on these and make sure that you've got these tuned in. So when we talk about balance, I mean balance in terms of too much or too little of each of the elements, but also we mean balance of all 4, focusing the right amount of energy on all 4 elements so that you're not neglecting one of them over another. Because all 4 elements, even though we may spend more energy on one than on the other, all 4 elements are equally important. Now notice that what's not here is nutrients and pH. And I point those 2 out because a lot of people believe that those are the most important factors that they're going to be spending their time and energy on. And in fact, as you'll see throughout this course, we're looking at a paradigm shift here. So you're no longer going to focus on nutrients and what amount of nutrients is in your soil and how much nutrients you need to add to your soil. We're also barely even going to focus on pH. Not that pH isn't important, but what you'll see is that when you start wrapping your head around this system and using these techniques, you don't have to worry about pH anymore. So why do we focus on the 4 elements? Well, really, it all goes back to how plants make energy and make sugars, which is really what we're measuring when we're measuring bricks in our plants. So this is kind of like high school chemistry, but just in case you're not familiar, plants make sugars through photosynthesis, which involves light energy from the sun or from a light source, involves water, and it involves air, or more specifically, carbon dioxide that comes from the air. So right there, we've got 3 of the 4 elements covered. And the 4th element, earth, actually, is involved in this process because, as we know, plant growth is not necessarily all just about photosynthesis. The plant needs to make these sugars, but it also needs mineral nutrients. And so those mineral nutrients come in from the earth. Not directly involved in photosynthesis, but still very important for the plant to produce sugars, and in fact complex sugars, which is really what we're looking for. Okay, so let's dive into these elements one by one, starting with air. Now, as you probably know, the air is actually composed mostly of nitrogen. In fact, 78% of the air is nitrogen, and most of the rest of the air is oxygen, with carbon dioxide being a very small amount of the air. Currently in our atmosphere, it's around 420 parts per million. Now, if you're familiar with greenhouse growing or indoor growing, you may have tried to increase the amount of carbon dioxide in your grow in order to stimulate plant growth. And this gets to an important point, which is that parts per million of certain elements in the air can have an oversized impact. They're very important. So we changed the CO2 by just a few hundred parts per million, which is a pretty small amount, and you can dramatically increase the amount of photosynthesis happening. The other thing to consider about ppms is what else might be in your air in your local area that probably shouldn't be there. So if you live in a big city, sometimes there's pollution that can get up into the few hundred parts per million of these various pollutants, and that can have an effect on the plant. Also, if you live on the West Coast, last year you probably experienced the smoke that was in the air and the ash from the fires that were all over the West Coast. And you may have seen that that can have a big impact on the plants as well. Not only does having that smoke in the air affect your plants, but also that ash, especially that ash falling from the sky, if it collects on the leaves of your plants, it will change the pH of the surface of the plants, which can have a number of different effects, but one of them is it can actually attract pests, believe it or not, and it's going to hinder your plant's ability to photosynthesize as well from blocking out sunlight. So these are all, they may seem like small things, but these are all things to consider when looking at your location of where you're going to grow, considering whether you're going to grow indoors, outdoors, or in a greenhouse, and things like that. Now the other area where air really has an impact, and this is honestly probably the most important impact of air on a day-to-day basis, is your soil aeration. So you've probably heard about the importance of soil aeration. And the reason it's important is because plants not only photosynthesize through their leaves, but they also respire, just like animals and humans do. They have to consume oxygen, and they do that through their root system. So the roots of the plants need access to oxygen in the soil. This also impacts water and the percolation of water through your soil. So to talk a little bit more about the soil aeration, because again, this is really where air makes a big difference on a day-to-day basis, you need to have well aerated soil in order to have healthy soil. It's not only for the air to get in, but also, as you can see, for water to be able to percolate down through the soil and be absorbed by the soil. If you have compacted soil, you're not only going to have a problem with aeration of your soil, but also with water absorbing into your soil. And we'll talk more about how to avoid compaction and make sure that your soil is well aerated through the process of improving your soil health and microbial activity. Now, another way to increase your soil aeration is by mechanical means. And this is often done with lawns and with turf grass and on farms. Mechanical aeration, meaning you're basically just drilling a hole down into the soil where you need to get it aerated. And this is effective, at least in the short term. You know, it does get air down into the soil. It does improve that aeration. The problem is that if you don't have healthy soil that can keep itself aerated, eventually those air tubes are going to collapse. You know, activity is going to happen on your farm. Maybe you're driving a tractor over, maybe you're stepping on the soil, you know, whatever. Those air holes are probably going to collapse eventually, and you're going to go back to having the same problem. And it's the same thing with including something into your soil mix for aeration, like is oftenly done with perlite or pumice rock, as you can see in this soil mix, incorporated into the soil mix for aeration. This is a physical means of aeration. Now again, not to say that this doesn't work, it absolutely does work. And it's good when you're starting out, but again, really the best way to get aeration is actually to improve your soil structure. And so we'll get more into that later. Okay, moving on to the second element, fire. In this case, really what we're talking about is light and energy. So this encompasses the daylight hours that you have, or just the hours of light that you have in your grow setup, direct versus indirect light, but it also encompasses things like temperature and humidity, because these are related to energy, and the sun's energy or the light energy impacts the temperature and the humidity of your growing space. And one of the really important parameters you want to pay attention to here is how quickly does your soil dry out, and how do you keep that optimum soil moisture. We'll talk more about that when we get to water. So I'm sure everybody knows plants need light, as we talked about, for photosynthesis, for energy. The real question is how much light. So some plants like a lot of direct sunlight. In fact, most of the crops we're going to be growing probably need at least 5 hours of direct sunlight during the day. And I say direct because if it's indirect light, like what you might have if you have a house plant indoors sitting in a window, that's often getting, or maybe it's not even sitting in a window, it might be sitting in a room. It's getting light, it's getting indirect light coming through the windows, but it's not direct light, and so photosynthesis is not going to take place as quickly. So for most crops you're going to grow, you want a decent amount of direct sunlight during the day. Now some crops like less direct sunlight, and it just depends on the climate that they originate from. You can look this stuff up on the internet pretty easily for each of your different crops, how much sunlight, how much direct sunlight do they like during the day. And you can keep an eye on your plants and actually observe if they're getting too much sunlight or not enough. You'll typically have some wilting and some shriveling of the leaves if they're getting too much sunlight or even too little sunlight. Now I want to talk a little bit about artificial light because I know some of you are growing cannabis indoors and using artificial light rather than the sun. So for the last few decades, it's just been kind of standard procedure to use high intensity discharge lighting, HID lights, like metal halide or high pressure sodium lights, because these were really the only lights that could produce enough energy to grow your plants indoors. But I'm here to tell you that that situation is now changing, and in fact we've gotten to a point where LED technology is going to perform the same or better than high intensity lighting. So don't let anybody tell you that LEDs don't work. Technology has advanced rapidly. Even if it wasn't working super well 2 or 3 years ago, today a lot of very successful commercial growers are using LED lights. Case in point, Green Life Productions in Las Vegas, one of the most successful indoor living soil cultivation facilities. They use LED lights, and they're saving a ton of money on their electric bill, not to mention actually getting better results because LED lights can better filter out the correct spectrums the plants need. Now, of course, you're going to want to talk to somebody about how to set up those lights and especially how far away to put those lights from your plant. Talk to the manufacturer or talk to the reseller about what success other people have had with the distance of those lights from your plants and how many lights you'll need for how many plants. You really want to get some expert advice on that because most commonly people who are switching from HID lights to LED lights will say LED doesn't work because they got the distance from their plants wrong. And it's a different technology, so the way that you're going to set it up might be a little bit different. So you want to get some advice on that. And the other thing to get expert advice on is on your particular genetics. Talk to the breeder, if you can, about what are the optimum conditions for those genetics. Because different cannabis plants or different plants that originate from different environments are going to have different optimal temperature and humidity levels, as well as potentially even lighting levels. Alright, so we moved through those two pretty quickly because honestly, once you get your lighting dialed in and once you get your air kind of dialed in, or you've gotten used to the climate that you're growing in, that's the kind of stuff that you can almost kind of set it and forget it. You don't have to focus a ton of your everyday energy on it. Where you're really going to be focusing a lot of your energy is on the water and the earth element. So we'll start with the water. This really comes down to, how much should I water? This is the endless question that growers are asking themselves, asking people in online forums, is this too much, too little watering? And another thing that a lot of people aren't really considering, but should be, is the source of their water and what kind of contaminants might be in that water. Then you also want to consider the potential beneficial minerals that are in that water. So this is actually an argument not to use reverse osmosis filtration. I've heard a lot of people talking about how they use RO water because it's the cleanest, purest water for their plants. But actually, they're being a little bit counterproductive by using RO because they're filtering out some minerals that could really be beneficial for your plant. So you want to balance, again, back to balance out filtering contaminants and allowing some minerals to stay in your water. And then if you get really advanced, you can actually start to crop steer with how much water you give your plants. A specific example of this is some growers have found that drought stressing their cannabis plants will lead to higher THC percentages. Now you have to know at what time to do that and how to do it well so you don't unnecessarily stress your plant, but it can be effective. And actually grape growers do this as well. When they're trying to get higher sugar levels in their plant, they may give them less water so that the fruit on the grapes actually has a higher sugar content. So again, back to the question of underwatering, overwatering, how do you tell which one? Because actually, oftentimes the symptoms of underwatering and overwatering look pretty similar, and it's a little hard to tell at first glance which one is the actual problem. So one way that you can tell is just simply by touching the leaves of your plants. Do they feel crisp or do they feel soft? If they're soft, it means you've probably overwatered. If they're crisp, it probably means you've underwatered. But really, I think the most effective way to tell whether you've underwatered or overwatered is just simply to look at your soil and figure out, is your soil too wet, is it too dry, or does it have just the right amount of moisture? In which case, you might be looking at a different problem besides under or overwatering. Touch the soil, see if it's too wet or too dry or just right. Now, of course, you can get a moisture meter to tell you this, and that may be more effective if you have a large commercial operation and you don't have the manpower to go around to all the soil and test it with your hands and make sure that it's moist enough. So soil moisture meter can be effective, and we'll talk in a second about an irrigation system that can help with that too. So when you're looking at your soil, you really just want to touch it and say, does it feel moist? Does it look moist? Is it a darker color like this soil? Or does it feel really dry and sand-like? And it's typically going to be a lighter color like this soil. And pretty quickly you'll start to be able to tell the difference. Now, another important consideration that I just want to introduce here, we'll talk more about this later, but is covering your soil. When you've got high intensity light on your soil, or you've got a lot of sunlight on your soil will dry out very quickly, and uncovered soil is going to lose its moisture very quickly. Versus a soil that's covered with either a mulch or a cover crop, as you can see here, is going to stay more moist. So as I mentioned, if you are growing in a large facility and you don't have time to check the moisture of all your soils, or you're a home grower and you're out at work all day and you just don't have the time to monitor your soil really closely, the Blue Mat watering system can be a really great solution for this, because Blue Mat is unique in that it actually senses the moisture levels of your soil, and you can dial that in to whatever level you want it to be at. Once you get that dialed in, then the irrigation system will feed water according to the moisture requirement that you set. And it will essentially, as long as you have a filled reservoir or you're directly connected to a water line, it will keep the soil at the moisture that you want. Very cool way to automate your grow. Now, another really important consideration for water is filtration. So I talked a little bit about this earlier. In order to filter out contaminants, if you live in a city, you're most likely going to have chlorine, maybe even chloramine, which is a stronger, more long-lasting version of chlorine that is harder to remove from the water. And a lot of city waters can also have certain different levels of heavy metals, dangerous heavy metals. Probably heard about the crisis in Flint, Michigan, where they had tons of heavy metals in their water. So for this, you can get really a pretty basic, relatively inexpensive garden hose filter that just attaches on to your hose or to your faucet and will filter the water in line for you. Don't really need anything super fancy. I used one of these in my garden and it worked just fine. look for something that is KDF and GAC. KDF stands for Kinetic Degradation Fluxion, and GAC, that's a granular activated carbon. So if you have these two steps in your filter, in your hose, you're going to be pretty good for removing all those contaminants you have to worry about in city water. You want to avoid water softeners. Those are going to introduce stuff that's not great for your plants. And then if you are living in a more rural area and you have well water, that can be a great thing. You just want to consider that if you're in a heavy agricultural area with especially a lot of conventional farms, even organic farms around you, you want to get that water tested for nitrate levels because it may have a lot of nitrogen fertilizer runoff in it, which you may think is not such a bad thing. You're getting some free fertilizer there, but for this system of growing that we're talking about, that's actually going to be more detrimental than beneficial. Also, the other thing you want to watch out for is pesticides, especially if you're surrounded by conventional farms. Pesticides and herbicides may be collecting in your water, so you definitely want to get that water tested before using it. Okay, and finally we get to earth. Now, earth is really going to be the major focus of most of this course, so we'll touch on it, some of the basic concepts here briefly, and then get into more about how we take care of our soil, the earth element, in many different ways. So first thing you're going to want to know if you're growing in native soil is, what is the composition of your soil? Is it sand, silt, clay, or are you one of those lucky people that has a loamy soil? You're also going to want to know what your soil organic matter percentage is. Again, for a native soil, this is going to be really important. If you test it and you find you're in the 1 to 2% range, that means you have a heavily degraded soil, and you're going to need to do a lot of work to build up that soil organic matter. If you're closer to 5%, that's a pretty decent soil, and if you're 10% or more, that's a really great soil, and you probably don't have a lot more work to do. We'll talk a little bit about what the difference is between soil and dirt, and then the rest of this course we'll get into how to build a living soil. So again, you may be familiar, but here's the different types of soil. So your soil type is not only important because of the particle size, which is how these are defined. Clay has the smallest particle size, sand has the largest particle size, and silt is in between. But also the electrical properties of these types of soil are actually different as well. Clay is going to be, it's much easier for clay to bind nutrients to it, and water, and clay can absorb water a lot better. Whereas sand, it's very easy for the water to go through and the nutrients, and you're not going to hold a lot of that in your soil. Now you can send away for a soil test for this, or you can do a very simple home test with jars, putting your soil into a jar filled with water, shaking it up, and then letting it sit for 24 hours, 48 hours. And that soil will settle out, and you'll actually be able to see the different levels, the stratification of the different types of soil, and you can calculate how much of each component your soil contains. So you can see here a little bit more detail about the different soil types, and in fact, interestingly, clay soil is a really big kind of outsized percentage compared to sand and silty soil. And then another important thing to understand is the different layers of soil. So most of your organic matter is going to be in that very top layer of soil called your O horizon. And if you're mixing a soil mix to grow in pots or raised beds, you essentially are creating an O horizon there, possibly an A horizon too. The A horizon has some of the minerals, like the sand, the silt, and clay. They start to get mixed into the soil in the A horizon. And you can actually build a soil mix that simulates these soil horizons. Leighton Morrison has developed a really great technique for doing that. If you go on the Shaping Fire podcast and listen to his episodes, he talks in detail about the whole system for building a soil horizon soil. And you can actually find it on YouTube as well. So that's it for our discussion of the 4 elements. Now this week we've got a worksheet for you to use that will help you to evaluate your growing environment and make sure that you've considered all the different aspects of the 4 elements that are going to affect your growth. So go into the course materials, find that worksheet. It shouldn't take you very long. It just has a few simple questions for you to fill out the answers to and really think about and evaluate the 4 elements in your growing environment. Again, remember to always keep these elements in mind as you're troubleshooting and evaluating your garden. Make sure that you're spending the appropriate amount of time and energy on these elements, and make sure these elements are always in balance with themselves and with each other. Balance and diversity is going to be the key. So thanks for tuning in to this lesson, and we will see you next week for our introduction to the soil food web.